The next question is describe how to find the reference angle of 19 pi over 5. So if you're going to actually be explaining this in words, you might say that you would sketch it and then find the distance or find how many sections there were from the terminal arm down to the x-axis. So just to show that, I'll do an example of actually finding the reference angle of 19 pi over 5. So again, if we're sketching, we have 5 as the bottom, which means we need to break the top and bottom into 5. So again, it's an odd number, so we're going to put that center section in there, and then we have to have 2 more sections on each side. So I have 1, 2, 3 hops right over that Y line for 5, and then I'm going to do the same thing on this side. So I have 1, 2, 3 hopping over the Y line for 5. And I need to count 19 of them. So I go 5, 10, 15, 16, 17, 18, 19. So 19 is going to be just 1 short of that x-axis. So that means the reference angle, or the distance I had to go to get back to that x-axis, is 1 single pi over 5. So in this case, my reference angle is pi over 5. The next question down here asks us what the general form of angles that are coterminal with 6 pi over 7. So that's the first part. What is the general form of an angle that's coterminal with 6 pi over 7? So remember, coterminal just means that whatever angle you have, let's say its terminal arm is here, if it's coterminal, it just means that even if I went around a whole bunch of times, my arm will still land in that same spot. So coterminal just means one single terminal arm, no matter how many times you went around. So to find 2 angles that are coterminal, or to find any angle that's coterminal, in general, to get the angle, I start with the original, so in this case 6 pi over 7, and I need to go around the circle however many times I want to. So I can go around in the positive direction, or I can go around in the negative direction. And to get around the circle, that's 2 pi. What's really important is that I add an n on there. And that n means that I can go around the circle or add 2 pi or subtract 2 pi as many times as I want to. So that right there is the general form for angles that are coterminal with 6 pi over 7. The second part asks you to actually find an angle that's coterminal with 6 pi over 7. So what I can do is use that same formula. I'm going to find an angle 6 pi over 7, and I just choose what I want to do. Do I want to add or subtract? So I can choose to add, and however many times I want to go around, well, why don't I just go around once? So that n, think of it as being a 1. 2 pi times 1 is just 2 pi, so I'm going to add 2 pi. The common thing here is to just add the tops, the 6 pi and the 2 pi, over, and then just have it all over 7. But that's not what's actually happening here. You have to be really careful when you add fractions that you make sure the denominators are the same. So if I want 2 pi to be written as something with a base of 7 or a denominator of 7, that means really what I'm doing is multiplying the bottom by 7. But if I multiply the bottom by 7, I have to multiply the top by 7. So I go 2 times 7 on the top, and 2 times 7 is just 14. And that makes sense too, because 14 pi's divided by 7 is just 2 pi. So now I have 6 pi over 7s and 14 pi over 7s. So I have a total, or my new angle is 20 pi over 7. So 20 pi over 7 would be an example of an angle that is coterminal with 6 pi over 7.